Okay, hello Cloud Gurus. Well, welcome to Lab 5. We're into the home stretch now. In this lab, we're going to connect Firebase to list out the videos. So in this lesson, we're going to introduce a database. And the database is going to hold a list of videos that are available on the website. So these are videos that have been uploaded and transcoded and are now available for our end users to watch. We're basically connecting everything together in the final piece here to make a completely usable website. So we're going to use a database with a bit of a difference called Firebase. Firebase is a NoSQL database, which is designed to be directly connected to your users in the browser. So users' browsers connect directly to Firebase to read and even to write data with no middleman, no middle servers in between. So we can still write to it from our backend, from our Lambda functions, allowing our transcoding pipeline to publish transcoding progress and results to the database. In addition, Firebase is a fully push-based event-driven system, so any changes made to the data are automatically pushed to all connected clients via WebSockets. So Firebase is actually a Google product offered as part of Google Cloud. Firebase provides a real-time database and backend as a service. In this course, we're showing you how to architect a system across multiple clouds. This is possible and it's not that difficult. Serverless architecture really enables this and allows you to use the best tool for the job. So the serverless architectural principle that applies to this lab is principle 4, to create thicker, more powerful front ends. And it's funny, if you think about a traditional 3-tier approach to application development, you've got the browser, which is your presentation tier. You've got the web server, which is your logic tier, and you've got the database, which is your data tier. And this layering keeps a really nice separation of concerns, but it becomes really tedious to maintain and to improve over time, and it's exacerbated in the world of rich single-page applications. Because in that world, when you've got a single-page app, you've got an entire MVC framework sitting in your browser. So inside your browser's JavaScript code, you've got views, controllers, services, and these services then have to talk out over the wire to your backend with a communication contract that you have to define and maintain. Then you have to maintain all of the layering inside your server, so authorizing calls, validating input, fetching models from the database, applying business logic. If you want to add a new feature to the product, you have to touch every single layer through the stack. And I think many architects and developers have worked on systems that have many, many more layers than this. This is kind of the basics. But in a serverless world with some smart technologies, your web application can now be made much smarter. It can load data and even write data directly from the Firebase database without needing to talk to a web server. It can talk directly to a range of services like Auth0 to perform specific user-related functions. And where custom code is needed, it can call out to Lambda functions through your API gateway. This keeps the majority of your code in the front end and in a single code base, and it reduces the number of layers in the stack and becomes a lot simpler to add new features and maintain existing code. Look at how few layers you need to touch now to change a feature. One point on this is really useful for particular types of applications, but this concept of removing the middle tier, removing the server layer, doesn't work in other scenarios. So you've got to pick your scenario. If it's important in your use case to have a really consistent versioned API and you have multiple clients, so you might have a mobile app, you might have a web app, you might have a desktop app, and they all need to talk to the back end and have things done in a consistent managed way, then you don't want to have to build the app 3 times all talking to Firebase. And essentially if you have most of your logic in the front end, then if you maintain multiple apps, you'll be having to rebuild most of your logic 3 times. So it really does depend on the system you're building. This is a great way to get started building a web-only or a single client application and get to market and innovate very, very quickly. In this lesson, we'll set up a Firebase database. We'll then have our website read metadata directly from it to learn all about the videos that are available for users to watch. We'll push some sample data into the database first in the lab, which points to some videos saved in an S3 bucket that we set up earlier. This allows you to kind of see the finished product. Then you can also play with the data directly in Firebase, like delete entries, modify them, and see how it affects the user interface. Next, we'll connect our Firebase data directly into our transcoding pipeline. Our transcode video Lambda function will be updated to write a flag into the database indicating that the video is being transcoded. We'll then make a new Lambda function. We'll hook it up to be invoked when a new transcoded video arrives in the destination bucket. So this new function will write the new transcoded video URL to Firebase and change the flag to say that transcoding is complete. This then allows all users who are connected and have the website running to automatically get that new file, get access to that new video through Firebase without having to poll. It's all done through WebSockets and events. Okay, so let's get stuck in.